Division of a curve is x cubed plus 3x squared y minus y cubed is equal to 3. Show that dy dx is x plus 2xy over y squared minus x squared. So there are two concepts that I'm going to emphasize for this question. Firstly, there is the implicit part. Right, whenever you are differentiating any term with y, you just do the same differentiation you have done for x, power times coefficient, and you subtract 1 from the power. And added to that, you should put a dy dx after your differentiation. So that's the first aspect of this question, implicit differentiation. Then the second aspect of differentiation that we have here is we may differentiate a product of two terms. When differentiating a product, that's u times derivative of v plus v times derivative of u. So those are the two aspects of differentiation that we are going to look at. All right, so we start. We differentiate x cubed. X cubed is going to give me 3x squared. Plus, now we take a look at this right there. This is a product of two terms. There is a 3x squared and there is also a y. U dv plus v du. So my u shall be the 3x squared dv. Derivative of y is a 1 dy dx. Plus v du, that's y times derivative of 3x squared, which is 6x, minus the derivative of y cubed, that's 3y squared dy dx. Don't forget, you put dy dx when you differentiate a y term, is equal to, then you differentiate your 3, which is a constant, and that gives you a 0. You are done differentiating. So what's left? You are just now supposed to make dy dx the subject of the formula. So how are you going to do that? We are going to remain with the dy dx terms on the left-hand side, and at the same time, we are going to factor out our dy dx. Dy dx factored out from this first term, that becomes 3x squared. Dy dx factored out from the second term, that's a 3, negative 3y squared, and it's equal to, you take all the other terms to the other side, terms without dy dx. So we are taking negative 3x squared away, negative 6xy on the other side. What happens after this? We then make dy dx the subject of the formula. We are going to divide both sides by 3x squared minus 3y squared. So what's going to happen when we do that division? These two will cancel out. We remain with dy dx is equal to, now on the right hand side, we want to make sure that this is matching with what we are supposed to show. But currently, there's not an exact match. We have x squared there, and we have negative 3x squared on this side. They have x squared. They also have positive 2xy. We have negative 6xy. So how are we going to get there? I've noticed that we are just supposed to divide every term by negative 3x. Negative 3 rather. Negative 3. I'll take that. again, yes. So we'll divide everything, each term individually, by -3. All right, so let's divide. Let's get our final answer. -3 into -3x squared. That will give me positive x squared. -3 into -6xy. That's going to give me positive 2xy over, we then say -3 into -3y squared, we get a positive y squared. Then -3 into 3x squared, we get a negative x squared. So yes, we've managed to show for 4 marks, which is quite easy. Two important concepts were the implicit and, of course, the product. Those were the two important concepts for that. All right, then part B of the question is saying, find the coordinates of the points on the curve where the tangent is parallel to the x-axis. So we discussed this one earlier on. When a tangent is parallel to the x-axis, this implies its gradient is 0. This also implies if you have your dy dx as a fraction, then your numerator, you can equate that to 0. So find the coordinates of the points of the curve where the tangent is parallel to the x-axis. So they want a full set of coordinates having both x and y. So we get our dy dx. Our dy dx, we managed to show that as x squared plus 2xy over y squared minus x squared. All right. So this is our derivative. This is our gradient function. And like I said, when a tangent is parallel to the x-axis, the gradient is 0. Of course, you can equate your dy dx to 0, or you can just equate the numerator to 0. It's still good enough. So we cross multiply denominator with 0, and the denominator is gone. So we now have x squared plus 2xy is 0. And then we can say x squared is equivalent to -2xy, which can end up being y is -x over 2. This is not a coordinate, but this is something that can help us come up with the required coordinates where our tangent is parallel to the x-axis. So we go back to the original equation that we had, x cubed plus 3xy x squared y minus y cubed, and it's equal to 3. So I've equated that to 3. So now what am I going to do? I'm going to substitute. I'm going to substitute what? I'm going to substitute my y being equal to -x over 2 so that I can find these coordinates. All right, so let's do the substitution. We have x cubed, yes, plus 3x squared. I'll take that again. So it's x cubed plus 3x squared. Then in place of y, I'll put -x over 2. All right, then minus y cubed. My y cubed, that's going to be a negative x over 2 to the power of 3. And the whole thing shall be equated to 3. Right, we simplify. X cubed will come back as x cubed. Then 3x squared times negative x over 2, I get negative 3 over 2 x to the power of 3. Then here I end up with a positive x cubed over 8. And the whole thing is equal to 3. All right. So now that I have equated this to 3, we now solve for our x. So solving for our x, what's going to happen? I'm going to have to add our x terms. Right, so we have 1 x cubed subtracting 3 over 2 x cubed, then adding 1 over 8 of x cubed. Right, so what's that going to give me? Let me get that from my calculator. I get negative 3 over 8 x cubed, and it's equal to 3. Then I divide both sides by negative 3 over 8, and I get an 8. So x cubed is equal to a negative 8, which means my x is a negative 2. And when x is negative 2, I substitute that here. That would give me my y as a 1. So the coordinates, x is negative 2 and y is equal to 1.